Let's take a look at integrating our exponentials. And much like yesterday, because differentiating exponentials is a very easy situation, well, integrating becomes similarly easy. The standard integral, which you get given in exams, has this basic one where they're just talking about linear functions. So if you have e to the power of a linear function, then it says, oh, well, the answer will be 1 over a, so the coefficient of x basically, e to the ax. That's okay if it's a linear function, but it's probably easier to think about it like we do with all those other things where we say, no, what we'd like to see is the derivative times e to the function x, because we know that if we've got the derivative times e to the function x, then I must have differentiated e to the function x. And then that will cover other situations as well, other than linear functions. So e to the 5x, as I say, you could look at that and think, oh, well, it's just a linear function, 1/5 e to the 5x. So for the simple ones, that's probably not a bad way of doing it. Of course, if you do think of it the other way, this is what you'd end up doing. You'd say, well, okay, e to the 5x, I want to see the derivative, so I would like 5 times e to the 5x, but to balance it out, I need a 5th out the front. So integrate 5 e to the 5x, I must have differentiated e to the 5x, and of course we get the same answer. So it's just which mindset are we in with those linear ones? As I say, for linear functions, just 1 over the coefficient of x is probably the quickest way of doing it. Now, this one, again, I can't do it the other way. It's not a linear function, so I need 2x out the front, but to balance it, it would be a half. And so therefore my answer is a half e to the x squared. I must have differentiated x squared to get 2x e to the x squared. E to the 9x minus 5, well, that is a linear function. So if I did it the other way, remember what I'd be saying is, what I'd like to see is 9 times e to the 9x minus 5. Let's balance it out. I'll put a 9th out the front. Either way, you'll come up with the answer 1/9 e to the 9x minus 5. The square root of e to the x, so be very careful with your index laws here. So e is actually to the power of a half x, or x on 2. So what I'd like to see is a half e to the x on 2. So I need to multiply by 2, not a half in this case, multiply 2 out the front to balance it out. So I'd have 2 e to the x on 2. That's probably good enough for a final answer, but I'm always in the habit of answering it like they ask it, so I'll put it back in third form. So 2 root e x. Okay, we don't have a product rule for integration, remember. So before I can do this one, I'm going to have to expand it out and just do it term by term. And remember, e to the x times e to the x is e to the 2x, not e to the x squared. So we get e to the 2x minus 2 lots of e to the x minus 3. Do each bit individually. Now I'm certainly going to think of it like the linear function. I know the e to the 2x is going to be a half e to the 2x. The e to the x just goes to e to the x. Again, there's that easiest question. And 3, of course, goes to 3x. Don't have a quotient rule for integration. So what does it say? Well, basically, top of the fraction divided by the bottom. Index rules, subtract the powers. So this question is really saying integrate e to the 3x minus e to the minus x. Okay. I've done it all in one hit, but be really careful with these negative signs, right? Because it's minus e to the minus x. To get that, you must have differentiated positive e to the minus x, because you would have said differentiate minus x, negative 1. So again, if you think of it as 1 over, coefficient of x is 3, so it's 1 over 3 e to the 3x. Minus coefficient is negative 1, so it's minus 1 over negative 1, so minus became plus e to the minus x. Very easy to make a silly mistake there, so be careful with those negatives. Let's do a definite integral. Powers x cubed, so I'd like to see 3x squared there. I've only got x squared, so let's balance it out. I'm going to have a third lots of 3x squared. I can now integrate. 3x squared e to the x cubed goes to e to the x cubed. Sub 1 in, although you can only just see it there. sub 1 in, we'll get e to the power of 1 minus e to the power of 0. Of course, e to the power of 1 is just e, and anything to the power of 0 is... No, it's not. I told you before, that's a lie. All right, because 0 to the power of 0 is not equal to 1. E minus 1 in this case, it is equal to 1 though, e to the power of 0. But it's not correct to say anything to the power of 0. All right, so we get a third e minus 1. Base is not e. All right, we just do it like normal, divide by a natural log of the base. So if this was e to the x, which is the world's easiest derivative and integral, I know the answer would have been e to the x. So here the answer is 3 to the power of x, but I'll divide by the natural log of the base. So log 3, plus of course a constant. Okay, there's enough little examples. So 13C, 13D, which I'm sure also involves some applications, some area questions, some volume questions and things like that.